I want to give an overview today of the effect of carbon dioxide, which is in the Earth's atmosphere, on the energy balance of Earth and the temperature of the surface of the Earth. What is the effect of carbon dioxide in our atmosphere? I'll talk in a fairly low level of science, and we'll investigate the science behind what I say in the next couple of sessions. So first of all, let me hit you between the eyes with this statement that Earth's surface is warmer than it would be if there were no carbon dioxide in our atmosphere. And let's explore why that is. First of all, a reminder. Earth's surface receives energy coming from the sun and loses energy by radiation from the Earth's surface towards outer space. And there's a condition of energy balance when the amount of energy coming in from the sun per unit of time is the same as the amount of energy per unit of time leaving the Earth's surface. In that condition of energy balance, the energy stays the same, and so the temperature stays the same. Now, here's the carbon dioxide in the atmosphere does not affect any of the radiation, the photons of radiation coming from the sun. But it does prevent some of the photons that are leaving Earth's surface from going out into outer space. The carbon dioxide in this atmosphere around Earth prevents some of these from escaping. It doesn't affect these ones coming in. So even at the low concentrations of carbon dioxide, significant proportion of the photons that are on their way to outer space don't make it. It's common to say, we're going to have to explore this, that carbon dioxide molecules capture photons of the emitted radiation, or they trap the photons of emitted radiation. So what does that mean? Aussie. What does that mean, Prof? Carbon dioxide molecules trap photons of radiation on their way to outer space? What do you mean they trap them? How can that happen? Yeah, well, I'm going to have to ask your patience here. I'm trying to give you an overview at a simple level of what happens, and then we'll explore the science of how and why it happens. Things are much more complicated than the message that's sent by saying that carbon dioxide molecules trap or capture photons, and we'll explore exactly what that does mean later on. Okay. Well, the other thing that's a bit very confusing is if carbon dioxide molecules don't let all of the photons go through the atmosphere on their way to space, how come they let all of the photons coming from the sun go through to arrive at the Earth's surface? It's the same atmosphere. How come they don't let those go through, but they do those? Or don't they? Again, absolutely crucial to understanding what happens with regard to carbon dioxide is this question that you've just posed. That carbon dioxide doesn't interfere with these photons coming in from the sun, but does prevent some of these from escaping. Simple story for now is that you might not expect that, because the atmosphere is the same These ones are passing through the same atmosphere as these ones are passing. So if what I'm saying is correct, and it is, these photons are different from these photons. And if you can wait a while, we'll talk about that. It's absolutely fundamental point you're raising. All right, let's kick on. Thank you. So I want to talk about what I might call the normal role, the continuing role of carbon dioxide, let's say, over the centuries before the Industrial Revolution. Then there was a state of approximate energy balance. Temperature didn't change much when the carbon dioxide concentration was roughly constant around 175 parts per million, 275 parts per million. Just imagine that we could instantly get rid of all the carbon dioxide molecules. Magic wand, they're all gone. Then suddenly, because the carbon dioxide molecules were trapping photons of irradiated photons of emitted radiations, the rate of emission into space would increase because there's none of the trapping going on. So there'd no longer be energy balance. And the rate of outgoing radiation would increase, and that would exceed the rate of incoming radiation. So the temperature would decrease. So carbon dioxide is keeping us warmer than would otherwise be the case. And this is called the greenhouse effect. How much warmer? Well, you just have to accept this. The average temperature of the surface of the Earth has been for centuries about 15 degrees Celsius. If there were no carbon dioxide in our atmosphere, the average temperature would be about minus 18 degrees, 33 Celsius degrees lower than it actually is. So that low concentration of carbon dioxide has an enormous influence on the energy balance, the average temperature of Earth's surface. So I hope that you're thinking already, well, if that little bit has such a big influence, then increases of a little bit more might also be significant, cause significant increases of temperature, more than we would like. Just by comparison, Venus, which is closer to the Sun than Earth, has got a much denser, more dense atmosphere than Earth has, and it's almost all carbon dioxide. And that's consistent with the fact that its average temperature at the surface is nearly 500 degrees Celsius. On the other hand, a bit further from the Sun is Mars, which with a much thinner atmosphere, its temperature is minus 47 degrees in the presence of lower carbon dioxide amounts. And that all makes a story. And what are the consequences of this effect? Well, at minus 18 degrees, for a start, all the oceans would be frozen. Life would be quite different. Raises the question, would there be life? Could humans survive, at least as we are now, in an environment where there's no carbon dioxide in our atmosphere? Could any animal species be present, as in the form that we now know them? Could any plant life be present under these circumstances, at least in the form that we now know it? Huge differences as a result of the carbon dioxide in our atmosphere. Aussie. Prof, you're telling us that we'd be in a bad way if there wasn't carbon dioxide in the atmosphere. And everything we read says we don't want to put carbon dioxide into the atmosphere. Carbon dioxide is bad. From what you've just said, it sounds like carbon dioxide's a good thing. I'm a bit confused. Look, Aussie, yeah, absolutely correct. Carbon dioxide is getting a very bad rap, and it deserves it. But it's also true that in the sense of continuing role. It's a necessary stuff in our atmosphere. Without that, things would be vastly different. Heaven only knows what form human beings and every other species would be like. So in that sense, it's good that we have the carbon dioxide that we've had for years and that we have adapted to as we've evolved and the other species have evolved. But it could be, and potentially will be, a very bad thing if the concentration of carbon dioxide goes much higher than that, and particularly if it goes higher than that more rapidly than we and the Earth's environment can adapt to it. So it's good in the sense of what we call the greenhouse effect, how carbon dioxide is keeping the Earth's surface warmer than it would be without carbon dioxide. But it's potentially bad in the sense of further increases of carbon dioxide, rather rapid increases of temperature, what we will refer to as the enhanced greenhouse effect. So, foreshadowing, getting a bit more scientific, what precisely is the greenhouse effect? Well, I've sort of said what it is. How does it function? We might read that carbon dioxide molecules trap photons of emitted radiation. Is that a good enough description? What does it mean in scientific terms? Well, we'll talk about that in our next session.